Okay, so we're going to do another problem. So right here, this is using function notation, okay? H of t represents height. Don't separate them. This is h of t, all right? Don't multiply them. This is not multiplication. This is just a label. Kind of like this is x and this is y. It's a label. We call it h of t. There's a reason and a purpose for it. If you don't quite understand it, don't mess with it right now. Don't separate it. Don't break it up. Just leave it. If you don't understand this part, don't break it apart. And just leave it. I'm going to try to explain to you what it means as we go through this problem. But if you don't get it, it's all right. You'll get there. It takes practice. The height h in feet of a ball thrown into the air is modeled by this function. This is the height based on time. And this is the function, negative 16 t squared plus 96t. T is the time. It's measured in seconds. Fill in the table below and sketch a graph of the function on the grid provided by connecting the points with a smooth curve. So what we're going to do is I'm going to take another sticky note, and we got to fill in this table. And how we're going to fill in the table, in case you've never filled in a table before, so this is h of t equals negative 16 t squared plus 96t. Okay, what we're going to do is t is going to equal 0, so we're going to plug 0 in everywhere we see t. So h of 0, so the height when the ball has been in the air 0 seconds, negative 16 times 0 squared plus 96 times 0. Well, this times 0 is just 0, this times 0 is just 0, so our height at 0 is just at 0. Okay, we'll try 1, h of 1, negative 16 times 1 squared plus 96 times 1. And this is about the time when a calculator would be very helpful. So I'm going to turn on my calculator. And here's how this goes. So h of 1, so 1 squared is 1 times negative 16 is negative 16 plus 96 times 1 is 96. So h of 1 is going to get me 80. All right. And if I make a mistake, don't laugh. Everybody makes mistakes. All right, h of 2, so negative 16 times 2 squared plus 96 times 2. If we simplify that, notice how my left side hasn't changed at all. It's just a notation. It's just a label. Don't break it. Don't mess with it, okay? 2 squared is 4. 4 times negative 16 is going to be negative 64. Plus 96 times 2, which is 192. And if we combine that, we get 128. So we're just filling out this table. And once we get to the end of the table, what we're going to do is we're going to graph it. Now, if you notice so far, our numbers are pretty large. So what that tells me about the chart we're going to make is the numbers for the x-axis down here will be very small, like 0, 1, 2, 3, but the numbers on the y-axis they'll be a little bit larger. So we're going to do h of 3, which is negative 16 times 3 squared, plus 96 times 3. So h of 3 is going to be 16 times 3 squared. 3 squared is 9. So this would be negative 144 plus 96 times 3, which is 288. So h of 3 is equal to 144. All right, so h of 4, negative 16 times 4 squared plus 96 times 4. So what we get is h of 4 is equal to negative 256, and 96 times 4 I think is also nope, it's not. It's equal to 384. And if I add those together, I get h of 4 is equal to 128. Hey, look, we repeated ourselves. See? All right, let's try h of 5. h of 5 is negative 16. Times 5 squared plus 96 times 5. So what we get here is h of 5 is negative 400 plus 96 times 5, which is 480. So you combine those, you get 80. And I'm going to tell you, number 6 is going to be 0, just to save us a little bit of work. All right, so our graph, we have to get a maximum of 144. So what we're going to do is we're going to start here at 0. And it looks like a good way to divide this, it would be, since it starts at 80, 20, 44, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 tallies there. So how about we'll go up by, it's 144? Let's go up by tens. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 110, 120, 130, 140, 150. All right. And then down here it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and so forth, but we don't need to go that far. So for 0, it's 0, which is nice. And for 1, it's going to be 80, so I'll go up to 80. 2 is 128, so we're just going to estimate 120 is about right here, so 128 would be somewhere right there. 144 for number 3, so go up to 140-ish, right there maybe. And then 128 again for number 4, so we're just trying to line that up. And number 5 is 80 again. And number 6 is 0. And if you connect the dots, you get a curve that looks like that. And what they want you to do here is, how far did the ball travel from 0 to 2 seconds? So look from 0 to 2 seconds, and you look, and it traveled about 128 feet. If you look in feet, height is in feet. So yeah, so this is in feet. Feet. All right, so 128 feet. What's the average rate of change for the first 2 seconds? And that's the same thing here. What we're doing is the first, so 1, 2, this is 2 seconds, so it's 128. So your point here is, to start is 0, 0, and your second point is going to be 2, 128. So use your slope formula. Find the difference of the y's, so 128 minus 0, and your x's, so 2 minus 0. So it's 128 over 2, so 128 feet over 2 seconds, because our time is in seconds. So that makes it about 64 feet per second. Okay? And so try these next ones on your own. See if you can figure these out. I think that would be well within your range of being able to do. So your average rate of change is 64 feet per second. And then I'm going to do one more video for this to kind of give you an idea. Okay?